LeetCode problem number 139, word break. So this problem gives us a string called S and a dictionary of strings called wordDict. And what we have to do is return true if the string S can be segmented into a space-separated sequence of one or more dictionary words. And here it also states that we can use the same word in a dictionary multiple times in the segmentation. So what I wanted to do is basically here, for example, the string we have is LeetCode and the wordDict is leet and code. So what it wants us to find out is whether or not we can break this up into perfect pieces that is inside the wordDict, which in this case we can because we have leet, which is the first 4 characters, and code, which is the last 4 characters of the string. Here it also shows an example of us reusing the word apple, right? So we can use it multiple times. And here it gives us another example where even though there is cat, right? There's cat, there's sand, and there's dog, it returns false, right? Because if you notice, if we use cat or use cat, right? Cat and sand, then we don't have another D for dog, right? But if you use dog, then we don't have anything that when we break out cat sand into, right? Because sand also uses a D, dog also uses a D, right? So it returns false. So the way I did this was to use a method called bottoms up again. So first here I'm storing the size of the string. So let's say the string I have is, for example, LeetCode, I guess. And then the word dictionary is leet and then code, right? So here in my DP I have a vector which stores the size, which stores an amount of characters of false values inside. So each character I'm going to be checking at that position whether or not it's possible to find a word that matches in the word string, right? That's why we need size plus 1. Size the 1 would be the 0, right? So 1, 2, so there is 8 characters here. So that means we will have 8 plus 1 false, right? Because it's size plus 1. 3, 4, 5, 6, 7, 8, 9. Okay, and the last one, we are going to set it as true because we know if we were to reach the last character over here, right, it means that we have solved the word, and the goal is to return the first boolean. So let's say LeetCode, for example, right? So we know leet is we know we can find actually we are solving it from the back. So let's say, for example, this character E, right? We know E does not exist inside LeetCode, so we keep this as false. We know D or DE does not exist inside our word dictionary, so we set it as false. So we set false until we hit this character C, and which you can see the word code exists inside our wordDict, right? So for this C, we're going to mark it as true. And I think it should be this one, right? CODE, right? So if we continue and do the rest, essentially this will become true as well, right? Because this L is dependent on whether or not we can solve leet, right? At the same time, we also need to check whether or not we can solve the characters in front of it, right? So in this case, we can because we know if dp leet, which is this, plus the length of leet, which is 4, So 0, 1, 2, 3, 4. So if this is true as well, meaning that we can move 4 more, and over here it says that it's true, meaning that we can solve lead on from lead onwards, right? Meaning that we can solve the word LeetCode using the dictionaries given to us. Right. So basically that's the idea behind this bottom-up strategy or algorithm. Right. So that's why here we have to set it as true, the last character is true. This will just indicate whether or not we have found the word. Okay. So as I mentioned, we are starting from the back. So that's why I have a for loop here which iterates from the back. So I is equals to 8 minus 1. Here I have another for loop which will iterate through the word. I'll do it like this. So the word we're at for now would be lead, right? And J would always stay at 4 for this case because all the words inside our dictionary are 4 in length. So J will always be 4. So let's say we are starting at the last character, right? Character E. So here we check first, right? Size minus I. So remember size is 8 minus I is 7. Is it more than 4? Right? In this case it's not. That means we know that there is no characters, or at least this E character does not even fit our first word lead. Right? So this if statement is ignored, and we go on to the next word, which is code. But same thing with code, since code is also 4 in length. So this statement over here, size minus I, would not does not fit inside our dictionary. So this if statement will be ignored. And this will go on until we iterate through all the word, right, which in this case we did, lead and code. So once that is done, we decrement I, right, so I will decrement to 6. And now we are looking at D and E. But for this case, since D and E is technically the same thing, because what you have is 8 minus I, which is 6. It's still lesser than 4, right? Because DE is of length 2, and the word we have in the word dictionary are 4 only. So spoiler alert, this will decrement until I is equals to 4, where we are at code now. Right. So let me refresh. This is lead. We are over here. I iterate to 4, and now size minus I, 8 minus 4 is equals to 4, right, which is the size of our character. And now we want to check whether or not the substring, so substring works like this. We're starting at I, character I. So in this case, LeetCode, I is at 0, 1, 2, 3, 4. So I is over here, and we are substringing 4 characters, right? 4. So 1, 2, 3, 4, which is perfectly fine. Which is perfect because that gives us a word code, right? So we're checking whether or not the current word code, right, the substring, so we're checking whether or not this substring equals to our current word, which it does not, because our current word is lead and the code we are at is code. So again, this if statement doesn't trigger, and we move on to the next word in our dictionary code. Now for this case, since both of them are the same, then we have to check again, right? So we have to check again, since we can solve for code, can we solve it if we are using code as one of the answers, right? So that's why we have this, right? So dpi, right now I is 4, plus the length of our current word, which is 4. This will give us dp of 8, right? And if you notice, dp of 8, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8 will return us the end of the string, right? Meaning that if we were to have code as one of the answers, this is a possible solution, right? Code is one of the possible solutions. So when that happens, our DPI, current DPI, which is 4, 0, 1, 2, 3, 4, this will be set to true. Okay. Once that is done, we break out of the current loop. But in this case, since we have iterated through all of the words in the dictionary, it does not make a difference. Anyways, we still have to decrement I and move on to the next word, right? Okay. So now, since I is small enough, this statement will always trigger, right? Because we are at big numbers now. But the substring we have does not have the word, right, we're looking for. Remember that we are substringing 4 characters only. Right now we're looking at TCOD and we're checking whether or not it is one of the words inside our dictionary, which it's not, right? TCOD is not. So we move on, decrement one more time. Now the substring becomes ETCO. Again, we cannot find anything. And this will repeat until we reach 0, where 8 minus 0 is obviously more than 4. And we are substringing from character I, which is 0, starting from L, and 4 characters, right? So 1, 2, 3, 4, we get lead. Okay, now that this is true as well, right, because our current word is lead, so we have to check whether or not with lead we are able to solve the string if lead were to be a possible answer. So the way we do this is dpi, which is 0, plus j, and j is 4, right? So this will give us dp of 4. And if you notice, 0, 1, 2, 3, 4, we know that from 4 onwards we can solve the string using the existing words in the dictionary, because we just now have tested that from code onwards we can solve it, right? That's why there was a true here. So since this was true, we can set dpi, which is 0, to true. So we can set this as true, which is the first character of our string. So when that happens, this for loop will end, or more like this for loop will be broken out, so we don't need to test for code anymore. This after for loop will end because I now has reached 0. It cannot decrement further. And then we return dp of 0, meaning the first character of our string, the dp first character, which is true, right? Meaning that we can solve this string using the dictionary words, right? That's why there was a true here. Okay, so once that is done, we return true, and that is basically the answer for the example given as well. Alright. Okay, hopefully you can see that this is a pretty straightforward question, but the solution to this can be a bit tricky if you don't know bottom ups beforehand. But either way, that's all I have to show. Thanks.